So a nice thing about matrices is we can use them to do many of the same transformations that we have been doing in the past. And how we do it is with various different operations. Okay, so we're going to look at 4, but before we look at those 4, we need to take a closer look. First of all, it's something called the coordinate matrix. We have a triangle here, right? And this triangle is graphed on the coordinate plane. It's got 3 corners, and each corner can be represented with an ordered pair. Well, what we can do is we can take each one of those ordered pairs and represent it in a matrix. Okay? We can draw a coordinate matrix. So I'm going to draw a coordinate matrix. Now, every coordinate matrix always has 2 rows. Okay? The top row represents the x, the bottom row represents the y. The number of columns is determined by the number of ordered pairs that make up your object, or make up the vertices of your shape. For example, here we would have 3, right? The first ordered pair here would be 3, 5 for that top point. The second ordered pair would be 6, negative 2. And the third ordered pair would be 0, negative 2. Okay? So this matrix, this 2 by 3, 2 by 3, 2 rows, 3 columns. This 2 by 3 matrix is our coordinate matrix. And we're going to keep coming back to this one as we look at some examples. So speaking of those examples, with the rest of your notebook paper, what I want you to do is I want you to divide it into 4 quadrants. A quadrant where we can put some notes on translation, a quadrant where we can put notes on dilation, quadrant where we can put notes on reflection, and a quadrant we can put notes on rotation. Okay? So what we want to do here is we want to be able to look at 4 different types of transformations and how we do them. So set that up real quick. Okay? The first one we're going to look at, we're going to zoom in on, I should say, is translation. Okay? So we're going to look at translation first. Translation is like a slide. In order to do translation, what we do is we use matrix addition. We're going to add 2 matrices. Okay? Here's how we do that. We take the coordinate matrix of our shape and add it to a matrix that represents the translation we're trying to do. Let's say we take that triangle that we started with, right? It had an ordered pair at 3, 5, 6, negative 2, and 0, negative 2. Okay? And let's say we wanted to move it left 4 and up 3. Okay, so we know minus 4 and plus 3. Right, we know that that's how it'll work with an ordered pair. So what we're going to do is we're going to set up a matrix that does that for us. All of the x's are supposed to move to the left 4. All of the y's are supposed to move up 3, plus 3. This translation matrix, okay, this is our translation matrix, and it's going to move those ordered pairs by doing these operations to the specific coordinate. Okay? The result that we get gives us the new ordered pairs of our object. Negative 1, 8, 2, 1, negative 4, 1. If we were to plot those, remember the top row is x, the bottom row is y, that would give us the coordinates of our new triangle that has been translated the way we wanted. Okay? So translation is the first transformation that we can do here. And we do it with matrix addition. Okay? The second one is the dilation box. Now, a dilation is both shrink and compress. Okay? A dilation scales a figure. Okay? So that may be something you want to jot down, that we're doing a scale. It either enlarges or reduces. Okay? So it either enlarges the figure or reduces the figure. Okay? What happens is we keep the shape totally the same, but we just change the size. And the figures are going to be similar. So when you studied similar figures in geometry, you looked at dilations. Okay? Here's how we do dilations in terms of with a matrix. We use scalar multiplication. Okay, so we take our matrix, remember we have that coordinate matrix representing our shape, and we're going to multiply it by a factor. And that factor is going to act as a scalar multiplication. So let's say you're dilating by a factor of 2, you're going to have a 2. With our matrix, let's say we wanted to dilate by a factor of 1/2. So we have our 3, 5, 6, -2, and 0, -2. And we're going to make it half the size. Okay? The resulting matrix would give us our new ordered pairs, right? So we'd have an ordered pair of 3/2, 5/2, 3 -1, and 0 -1. Right? Because we're going to use that half right here. That sets the tone. Right? This says that we're dilating by half. And so we use that half to scale each part of the coordinate and therefore dilate the entire figure. Okay, so we use scalar multiplication. Those first two are pretty easy. The second two get a little bit tougher. The next one we're going to talk about is reflection. Okay? In order to reflect a figure, we do matrix multiplication. And what we do is we take a reflection matrix, usually a 2x2. It'll always be a 2x2. And multiply it by the shape matrix. No matter how many columns this has, our reflection matrix is always 2x2. Okay. So for example, let's say we wanted to multiply across, oops, my bad. Multiply across the y-axis. To do that, and you want to be sure you write this down, we would use the matrix -1, 0, 0, 1. That is the matrix we use for reflecting across the y-axis. So we multiply ordered pair, or our ordered pair matrix by that one. Whenever you're doing this, your transformation matrix, here it's at -1, 0, 0, 1, that has to come before. It must always be first. Right? What this matrix does is, yeah, it's going to be multiplying, but this -1 changes the x value. This +1 keeps the y value the same. Okay? And I'll show you kind of how that works as we go through and determine what our new ordered pairs would look like. Okay? So we do -1 times 3, 0 times 5, and get -3. And then we do -1 times 6, 0 times -2, -6. And then we do -1 times 0, 0 times -2, that's 0. Okay? Notice the x values are changing. The y values, 0, 1 times 3, 5 is 5. 0, 1 times 6, -2 is -2. And the last one's -2 as well. The y values have stayed the same, which is what we wanted. We literally just wanted to flip it so that the x values changed. Okay? Just something else you should write down really quickly. If you want to go across the x-axis, we're going to use the matrix 1, 0, 0, -1. Okay? So make sure you get that written down. If you're going to go across x, this is the matrix that you're going to want to multiply with. Okay? So that's reflection. We got one left to do. Last one's a little bit different because there's not a specific matrix that you're going to use. The rotation matrix will be given to you, but you're still going to use multiplication. You're still going to be using multiplication. What you're going to do is you're going to take, and you're going to be given a rotation matrix. It will be 2x2. It'll be 2x2. Then you're going to multiply that by your shape matrix. Okay? This rotation matrix is given to you. You're not going to be asked to know any of them. Okay? It will be different every time, and then maybe you'll have to interpret how it is. But no matter what, you're still going to be multiplying. Okay? You're still going to multiply. So, altogether we have these four. Just a quick run through. Back this train up for a second. First one is translation, and for translation we use matrix addition. The second one was dilation, which scales the figure by either reducing it or enlarging it. And we multiply with scalar multiplication by a given factor. Third one is matrix multiplication so that we could reflect. And we had two different ways of reflecting across y or reflecting across x, depending on what the problem asks you to do. Okay? And then the last one was rotation, and we said the last one they would give us a particular matrix to multiply by. Okay, so 4 different transformations that you are going to be able to crank out using only matrices. It's going to be awesome.